Okay, for warm-up 9, 8, or 9, I'd like you to copy all this work and the secret words, of course. Please do not share those words with anybody. I'd like you to start by writing this equivalent or not. We're looking at two new types of expressions, that you're seeing if they're equivalent or not. All right, so if I give you two expressions like this, like problem number 1, where 5 has an X on it, and then this 6, notice there's no X on it. If there's no X on both numbers, you cannot add these together. You can't add those together to get 11X. Those are called unlike terms. So if they asked you if they're equivalent or not on the exam, you're going to have to explain in words. And this is what I'd like you to write. No, not equivalent. You cannot combine two unlike terms. If you plug in, like pick a number, like maybe 3, X is 3, you get different answers. And again, you're going to be having to type that. Today I'm just going to have you write all of this and then show me if you have 5 and you plug in 3 and add that to 6, it's going to give you 15 plus 6 gives you 21. I need to show that. If I take 11 times 3, that gives me 33. I could see these are not equal, so those are not equivalent. No. First word is frog. If on the other hand over here, if I give you two terms with X in it, then yep, yippee skippy, you could combine those to get more of those X's, 11X. So for this one, yes, they are equivalent. Again, you're going to have to type and write complete sentences. You can combine like terms. Those are like terms. They both have X's. If you plug in, and let's pick a different number for X, maybe X equals 4, you get same answers. So again, if I was to plug in 5 times 4, and again, I need you to show this and write this for full credit, 6 times 4, that would give me 20 plus 24 gives me 44. If I was to plug in 11 and then times that 4, you can see I get that same 44. So that proves these are equivalent. Even though 5x plus 6x looks different, they are equivalent to 11x. All right, let's keep going. Those are the first two. All right, from the other day, looking at these expressions and distributing. So if I take a look at this top one here and I distribute it, that gives me 7x plus 28. It's going to be up to me to look at these others and see which also equals 7x plus 28. Second word is dog. Dog. So obviously, if I look at 7x plus 4, that's someone who forgot to times both. 28x, maybe just multiplied. Right here, there's the golden ticket. That is equivalent to 7x plus 4. Again, even though these look different, they are equal. They're equivalent. And then x plus 28, no good. Problem 4, a little bit harder, because these choices, you got to distribute them all. So sometimes you have to distribute from this back side, 6 times 6, 6 times 2x. That gives me 12x plus 36. So I can see that is equivalent. Even though that doesn't look the same, they are technically equal. They are equivalent. If I take a look at the second one here and distribute it, that gives me 12x squared because I'm timesing two of those x's, and I get that 12 by timesing 3 and 4. So 12x squared plus another 36. Don't forget that x. And I can see that looks close, but too many x's, not equivalent. If I take this guy, distribute, gives me 12x plus 36. I can see that one is equivalent. And then the last one, if I distribute, it gets close, gives me 12x, looks like I'm on the right path, but then it gives me 40, which makes that not equivalent. So only those two. All right, let's move on. Last problems. Next word is log. Log. All right, so for this, again, still got to remember left to right. Add the 6 and 3 first. Get that 9. Bring down the minus, the 4, the plus 1. Don't get 5 right here. Don't add that. Leave that alone. 9 minus 4 gives me 5. Bring down the plus and the 1 and get that 6. People will do that wrong. They're going to subtract 9 minus 5 and get 4. They're going to chunk it. Don't do that. If I have parenthesis work here, do the work inside both parentheses first. This gives me 3. Bring down the second power. Bring down the plus. Do that math in there. Get that 5. Don't add. Don't get 7. Look at the sign. 3 times 3 is never 6. It's 9. So that gives me 9 plus 5, which is 14. This one has you plug in, and this time I'll plug in the right number, n is 6. So I'm going to plug a 6 here, a 6 right here, and then make sure I just follow one step at a time. So I got 3. Right here I'm going to plug in the 6. Still got that second power. Leave that 5 times 2 alone. Here I plug in another 6. Now I do this 6 times 6 part, and I do this 5 times 2 part. Remember, 6 times 6 is never 12, 36. That gives me 3 plus 36 plus 5 times 2, 10 minus 6, left to right. 36 plus 3, 39 plus 6. I'm sorry, plus 10 minus 6. 39 plus 10 gives me 49 minus 6 gives me 43, I believe. Next word is polywog. Polywog. All right, and then the last one, how many of these 2's does it take to times to get 128? And how many 2's it takes is going to be that answer for X right there. So for this one, I just like you to start maybe with just a couple 2's. Maybe let's make it a little more easy to follow. So here's a couple 2's. If I multiply 2 times 2, that gives me 4. So I could see not quite 128. I need to keep multiplying. So if I multiply that by one more 2, that means I'm now multiplying, now multiplying by 3 of those 2's. It gives me 8. Need to keep going. So that means I'm going to times by another 2. Put another 2 here. Another 2, which means at this point, I'm really showing the work for timesing 4 of those 2's. 2 times 2, 4. 4 times 2, 8. 8 times 2 gives me 16. Got to keep going. Times another 2. This gives me 32. Oh no, I need to keep on going. 32 times another 2. So I'm up to 1, 2, 3, 4, 5, 6 2's so far. And then 32 times 2 gives me 64. Looks like I need to multiply by another 2. tricky keeping track of your 2's. And then 64 times 2 gives me 128. There we go. That's how many 2's it took to get 128. Count them up. 2 times 2 gives me 4. That's 2 of them. 4 times 2 gives me 8. That's 3 of them. 8 times 2 gives me 16. That's 4 of them. 16 times 2 gives me 32. 5 of them. 32 times 2, 64. 6 of them. 64 times 2, 128. 7 of these. 1, 2, 3, 4, 5, 6, 7. That means if I had the answer for X, it's 7. But remember, I would like you to write it like this. 128 equals 2. And then put that 7 in its home where it lives. That's where it lives to make this a true equation, equivalent equation. All right, last word is cat. Cat. Good luck. If you're done, check your grades, do makeup work, relax.